After studying this module, you shall be able to know about air pollution and their sources. The second thing is to learn about the impact of these pollutants on environment and human health. The third is to identify the components of different air pollutants. And lastly, to evaluate the techniques for analytical study of these pollutants. So let's start. First thing is introduction. What are air pollutants? Air pollutants basically considered substances which changes the qualitative composition of air in relation to the average composition. It is involvement of a substance in the air that can have adverse effects on human and the ecosystem. The substance can be solid particles, liquid droplets or gases. They can be natural or man-made. These pollutants are primarily produced from physical processes or some chemical processes. But some pollutants are not emitted directly. They appear when primary pollutants react or interact with each other, and that's why they are known as secondary pollutants. Some examples of air pollutants are carbon monoxide and sulfur dioxide that are released from vehicles or factories. The first thing you will ask me about the measurements of concentration of these air pollutants. We can do it. A great number of technologies and instruments are available for sampling and determination of the concentration level of these different components of air pollution in environment. These include chromatography, infrared spectroscopy, fluorometry, spectrophotometry, and atomic absorption spectroscopy. The pollutants which results in air pollutions are predominantly released from industries. The determination of concentration of these pollutants is important to analyze the extent of pollution in any particular area, and it helps to recover a good environment by accepting
several control measures.
The concentration of air pollutants is high in urban areas as compared to the rural areas because the urban areas are located near to the industries. Then what are the advantages of measurements of air pollutants? There are several advantages. The use of appropriate methods and analytical techniques in practices for air study provide information necessary for estimation of qualitative composition of pollutants. It helps in study of processes in the atmosphere and interaction range of particular pollutants. It also helps in estimating the exposure rate and accumulation of pollutants in living organisms. This is very important. So, to cite some of the example of toxic gaseous pollutants, there are many different sources that contribute to air pollution, which negatively affect public health and environment. Toxic gaseous pollutants are one of them and contribute to air pollution in majority. They are basically emitted from industrial activities or automobiles, power plants and factories. The analytical methods can be used for measurements of these air pollutants. Among the common gaseous pollutants, the general are sulfur dioxide, hydrogen sulfide, oxides of nitrogen, hydrogen fluoride, chlorine, hydrogen chloride, hydrogen cyanide, ammonia, carbon monoxides and ozone. For monitoring CO, CO2, NO2 and SO2, instruments based on spectroscopic techniques, mainly infrared and paramagnetic properties are frequently used. For
low concentration of oxides of sulfur and nitrogen,
a chemiluminescent method can be applied. Also, fully extractive systems can be sometimes used, especially when the air samples contain components which are easily soluble in water. Now, I will take example of sulfur dioxide as a pollutant. Sulfur dioxide is one of the most important air pollutants. It has very high corrosion rates, plant damage and general toxic effects. The determination of low concentration of sulfur dioxide is a challenge. The problem associated with its determination is sampling of these pollutants. If you take example of sulfur dioxide further, it is stable in the atmosphere for 2 to 4 days. The concentration of sulfur dioxide can be determined when the air sample is bubbled through a aqueous dilute solution of sodium tetrachloromercurate. containing sulfamic acid. It destroys any nitrogen oxides present in the air. In the whole procedure, sulfur dioxide present in the air sample reacts with
sodium tetrachloromercurate
and it gets converted into non-volatile complex sodium dichlorosulfitomercurate. There are many reactions and you must have read in your lectures. After the formation of complex, a mixture of p-rosanilin dye, formaldehyde and phosphoric acid is added and
para-rosanilene sulfitomercurate is formed.
It results in the liberation of sulfur dioxide
from sodium dichlorosulfitomercurate
complex and helps to maintain the pH of the reaction at 1 and can combine with heavy metals, ions along with sulfur dioxide in the environment. The concentration of sulfur dioxide in the atmosphere is directly proportional to the concentration of
para-rosanilene methyl sulfonic acid,
which can be determined colorimetrically. So it is easy. Now take example of nitrogen dioxide. Contaminated air contains nitrogen dioxide
which is bubbled through a solution of
sodium hydroxide. This results in the conversion of nitrogen dioxide into sodium nitrate, sodium nitrite. And
the product is then passed to a mixture of
hydrogen peroxide, sulfonilic acid, hydrochloric acid and naphthyl ethylene diamine dihydrochloride. The sodium nitrite so formed is then diazotizes with sulfonilic acid and the diazonium salt couples with naphthyl ethylene diamine dihydrochloride. The concentration of nitrogen dioxides can be determined by Lambert-Beer's law by determining the concentration of coupled compound using your spectrophotometer. Now another example of air pollutant is carbon monoxide. Carbon monoxide has a characteristic infrared absorptions near 4.6 micrometer. The absorption of infrared radiation by CO molecules therefore can be used to measure CO concentration in the presence of other gases. It is based on the fact that carbon monoxide or CO possesses a dipole moment which absorbs infrared radiation.
Non-dispersive infrared analyzer. The non-dispersive infrared analyzer is made up of having a sample cell in which sample of polluted air can be kept and a reference cell containing pure air. The infrared beam from a source is reflected by choppers alternately through the sample cell and the reference cell. The intensity of the beam emerging from sample cell is decreased since carbon monoxide absorbs infrared radiation. The beam then strikes a detector containing carbon monoxide and a movable diaphragm. The carbon monoxide in the detector absorbs infrared radiation and becomes hot, and the portion of the detector which faces the sample cell receiving lower intensity of infrared radiation is less hot. The diaphragm moves from the low temperature portion to high temperature. This tension of diaphragm is proportional to the difference in intensity of infrared radiation, which is then proportional to the amount of carbon monoxide present in contaminated air. Non-dispersive infrared systems have several advantages. They are not sensitive to flow rate, they require no wet chemicals, they are reasonably independent of ambient air temperature changes. They are sensitive over wide concentration ranges and these systems may be operated by non-technical personnel. Resonance fluorescence. Resonance fluorescence of carbon monoxide in the vacuum ultraviolet has been used for highly sensitive instrument. In this technique, atmospheric carbon monoxide absorbs radiation in the range of 150 nanometer from a radio frequency discharge lamp and fluorescence from the excited carbon monoxide is detected by a photomultiplier tube. The lamp generates plasma in a continuous flow of carbon dioxide in argon. The pressure in the fluorescence chamber must be maintained between 7 and 9 bar to balance interference from oxygen and carbon monoxide signal. Permeation tubes can also be used for preparing standard mixtures of such pollutant gases as sulfur dioxide and nitrogen dioxide. In the permeation tube techniques, a sample of the pure gas under pressure is allowed to diffuse through a calibrated partition at a defined rate into a diluent gas stream to give a standard sample of known composition. Another possible way to liberate known amounts of carbon monoxide into a diluent gas is by thermal decomposition of nickel tetracarbonyl.
Remote laser detection.
It is an open path infrared detector and can scan a wide area. It is used for detecting gas leaks from a distance, therefore, it is widely used to inspect areas such as processing plants, storage tanks, overhead track, mounted piping, and compressor stations. In the whole process, first the laser light beam is projected on a target, a fraction of beam is scattered from the target surface and returned to the source. The light which is returned is then collected and focused onto a detector. The presence of methane in the air is detected by the return light and the reading for this is displayed in parts per million in meter. Suspended matter and photochemical smog. Analysis of suspended matter. In order to determine the extent of air pollution by particulates, one of the most widely accepted methods is to determine the amount of dust that settles from atmosphere or that is washed from the air by rainfall. The determination of dust fall is made gravimetrically on samples that have been collected for a given period of time. A perforated polished aluminium box containing a polyethylene cup is used for collecting dust. In areas where wind velocity is high, the inside of the polyethylene container is coated with grease. The dust sticks to the grease and is not lost by wind action. In very cold places, a volatile antifreeze like isopropanol is added to the dust collector so as to avoid these freezing of rainwater. The aluminium box is placed in an open place. The treatment eliminates any moisture which may have adhered to the collector. The polyethylene cup is then heated for 1 hour and the weight of the particulate in the container is determined. X is equal to A upon pi b squared, where A is the weight of the dust in milligrams and B is the radius of the container. In order to collect the total dust collected in the polyethylene container
It is washed with a jet.
of hot distilled water, the washings are qualitatively filtered in an evaporating dish. Water is evaporated from the filtrate by heating the sample
Which is then dried by further heating the dried sample followed by washing.
And the amount of water insoluble dust is calculated. Y is equal to A minus C, where C is the weight of soluble particulates. Analysis of constituents of photochemical smog. The main constituents of photochemical smog originate from automobile exhaust. The main constituent of smog is the oxides of nitrogen, nitric oxide, and nitrogen dioxide. The formation of smog initiates with the photolysis of nitrogen dioxide, and the oxygen released from this reaction most of the time reacts with the molecular oxygen to form ozone. Therefore, the intensity of photochemical smog can be determined by measuring the concentration of ozone. For determining the concentration of ozone, polluted air is bubbled through an acidified solution of potassium iodide. The reaction results in the formation of triiodide ions whose concentration can be determined spectrophotometrically. A most significant contribution to the analytical chemistry of ozone is the ozonolysis reaction for determining ozone in air. 4,4-dimethoxystilbene as the reagent. The resulting ozonide reaction product cleaves to form acetaldehyde, which can then be determined by colorimetric reaction. The reaction can be modified by using 1,2-di-4-pyridyl ethylene as reagent and will take place. There is also a rapid, reliable, and specific method for ozone determination.
In this method, eugenol is used as a reagent that would cleave to yield formaldehyde quantitatively.
The final product is determined spectrophotometrically by using pre-rosanilene hydrochloride.
Now, how we can determine other pollutants, because there are other pollutants which are also present in our atmosphere. Yes, we can do it. Some other pollutants such as chlorine, ammonia and hydrogen cyanides can be determined by infrared spectroscopy. The organic pollutants collected and concentrated from air can be determined by freeze out techniques. Gas chromatography is a great method to study the organic pollutants. The analytical measurements of inorganic particulate pollutants is also equally important. The atomic absorption spectroscopy is used for the evaluation of metal concentration. The method has great advantages of selectivity, sensitivity, and modification of this approach by introducing a diethiocyane extraction step to concentrate and stabilize the metal before atomization and determination by atomic absorption spectroscopy. So, in this method, ethyl propionate is used as a solvent. As it is free from any hazard to environment, the use of mixed ligands causes the extraction of metals into ethyl propionate,
which can be extended
to include most of the metals. The inorganic pollutants, which includes arsenic, beryllium, cadmium, cobalt, lead, nickel, silver and zinc, can be concentrated and stabilized through complexation with a dithiazone oxime
acetylacetone
mixture, followed by extraction into ethyl propionate and determined by atomic absorption spectroscopy. So, today we have learned different methods which can be used to estimate the concentration of different toxic gases and many other pollutants in the atmosphere. To summarize, The air pollutants are primarily produced from physical and chemical processes, but some pollutants are not emitted directly. They appear when primary pollutants react or interact with each other. That's why they are known as secondary pollutants. Determination of concentration of pollutants is important to analyze the extent of pollution in particular area. Toxic gaseous pollutants are one of them and contribute to air pollution in majority. They are basically emitted from automobile industries, power plants and factories. The analytical methods for measuring concentration of air pollutants include chromatography, infrared spectroscopy, fluorometry, spectrophotometry and atomic absorption spectroscopy. The most dominated air pollutants are oxides of sulfur, nitrogen and carbon. Photochemical smog, suspended matter and greenhouse gases are also contributed to air pollution. Some other pollutants such as chlorine, ammonia and hydrogen cyanides can be determined by infrared spectroscopy. I am sure today we have learned how to estimate different toxic gaseous elements in the atmosphere as well as other pollutants in the atmosphere.